Good day and welcome to today's DUOT Technologies webcast as part of the Planet MicroCap Showcase. It is now my pleasure to turn the floor over to your host, CEO Chuck Ferry, and CFO Adrian Goldfarb of DUOT Technologies.
Hello, everyone. I'm Chuck Ferry, the CEO for DUOT Technologies, and I'm joined here today with my CFO, Adrian Goldfarb. It's a pleasure to have the opportunity to speak with everybody here for about the next 20 to 25 minutes. DUOT Technologies, we're headquartered here in Jacksonville, Florida. We're a small but publicly traded company, of course. About 60 employees, a little bit less than that. Very, very heavily focused on engineering of all flavors, software, artificial intelligence, and project management. The company's been around since about 2001, and we design, we develop, we deploy, and then we operate turnkey technologies with a combination of hardware, software, artificial intelligence, and information technologies. A little bit about our management team. You can see my mugshot there on the top. I've got a number of years leading both military and private sector companies. I previously served as a CEO for APR Energy and has also previously been the general manager for Arma Global, which is a defense contracting company, and then previously spent 26 years in the United States Army as an enlisted man, NCO, and officer in infantry, ranger, and special operations units, and with 48 months of time in combat. The team below me is surrounded by just a terrific team. David Ponovac, our Chief Artificial Intelligence Officer, and has been with the company for some time, and we'll show you a video of him a bit later talking with Adrian, our CFO, about some of our technology. Ben Iser has worked for me about 4 different times now. The first time was an assignment in Afghanistan as a Chief Operating Officer. Scott Carnes has been with the company for over 20 years, has been our Chief Commercial Officer, focused heavily on inside the rail industry. Adrian Goldfarb, who will speak a bit later today, has been with the company for some time, has a very deep background running publicly traded companies, and then Connie Weeks, our Chief Accounting Officer. A little bit about the company in kind of timeline of where the company's been. Since 2001, really, it's been through a series of delivering technical solutions for customers. Our first generation rail inspection portal was back in 2007, primarily focused on kind of the security aspects of seeing trains. We then began to add additional software as well as hardware sensor platforms into the solution. And really in 2018, we began not only the rail inspection portal solution, but also our automated logistics information system, which is a similar product that we'll talk to later. In 2019, we began adding our artificial intelligence offering. And in 2020, the company was uplisted onto the NASDAQ, trading under the symbol DUOT. So what we do is we really deploy cutting-edge technologies that transform precision railroading as well as the way logistics and intermodal operators operate. What we're really trying to do is help those industries improve their safety, improve their productivity or their throughput, and really that word, improving their velocity. So where you have large trains that have to stop and be inspected, or where you have large quantities of trucks trying to enter and exit large logistics or intermodal yards, we're trying to make that more reliable. We're trying to make it safer. we're trying to make it more efficient. Next. A little bit about our market. So the opportunity really is heavily inside the rail sector, primarily working with our Class 1 rail operators, very, very large companies, of course, and then large logistics and intermodal operators that are commercially operating, but also U.S. government customers. We've already talked about what we're trying to do with those customers. One of the key things that we're trying to do in the rail industry is right now the Federal Rail Administration and AAR require a physical inspection of trains that requires them to be stationary and standing. We are working with our Class 1 rail customers to eventually change those regulations, which will allow this automated inspection, which will be done at speed, as you've seen by the video. We're working to offer additional pricing models. That is, currently we primarily operate where we sell the equipment or CapEx model. We're starting to now offer service models or OpEx models that allow the customer not to have to put as much capital into the solution, but then use that to increase our long-term profitability and revenue stream. Our strategic partnerships include, obviously, our Class 1 rail customers. They're our most important strategic partners. But we also work very closely with companies such as Dell, NVIDIA, IBM, and a number of other very, very large companies in offering our solution. We're a performance-based workforce, so we are small, but we're mighty. We have tremendous talent inside the company, and we're continually improving that to have a highly incentivized, high-achieving workforce. So along with our solution is primarily focused on that rail, logistics, and intermodal customers, but really our technology is agnostic. And I think as we go forward in time, we will begin to see our technology and our solutions go into some of the other industries. We are heavily focused on our intellectual property. We currently have 10 patents that we manage and a number of trademarks. Those are very important to us, and we're currently in the process of adding 2 additional patents, and we'll talk to that in a moment. Here next, I'd like to show you a short slide here, and then we'll go into a video. But the rail inspection portal is really a large shed that is stacked full of sensors. They're optical sensors, speed sensors, laser sensors, and all of that takes very, very high real-time, high-resolution pictures, and then is processed at the edge in a large set of servers that are right nearby that produces, through a set of software and artificial intelligence, some instantaneous reports that show the health and status of each rail car, where we're now inspecting. Initially, we were doing about 20 inspection points. Now we're starting to inspect upwards of 60 or 70 inspection points, approaching the FRA mandated inspection checklist. Inside our rail inspection portal, it's really modular. So we have additional modules. You'll see those on the right-hand side. Our APIS system is able to photograph the top portion of the rail car. Our vehicle undercarriage examiners come in several forms. One is a normal line scan camera. That's the view. We have a thermal view, which uses a thermal camera to detect a different type of heat inspections. And then we've just brought on board our new oblique view. It's a set of 10 high-resolution cameras. We've just developed this, and this is undergoing patent reviews, patent applications right now as we speak, and we'll show some videos of these items here in just a moment. And so we'll show you this next.
Explain to the viewers kind of about the rail and how that actually works. Because I think people don't generally understand. They think it's just some cameras taking some pictures, but it's much, much more than that. So.
It is much more than that, Adrian. Very much so. It is. Imagine a portal. Any fans out there of the movie Stargate, where they're going from one side of the universe to another? It's a portal like that. The train zooms through the portal, and there are a series of sensors around that perimeter of the portal, right? So you got cameras looking down, you got cameras looking at the side, you got cameras looking at the bottom, and other sensors, lasers, vibrational sensors that are surrounding the train, 360 degrees. And as the train goes through the portal, main line, by the way, so this is at speed, we collect various types of pieces of data that are then glued together and shown to the customer, right? And this is all in near real time. You know, you're talking delays of milliseconds, right?
Yes, yes.
So within milliseconds, what you do is you assemble those individual line scan stripes into panoramas for each rail car. You also pair it with obliques, because we not only have line scans, we have oblique cameras that are looking at the weird, odd angles that are normally not seen perpendicular to the car.
Right, right.
And then we have other pieces of data, like laser for profiling, for example, or vibrational data that we use for strikes. You know, if the train is dragging equipment or something, you want to know. It is a serious problem for the railroad. So once the train zooms through, we assemble each rail car and show it on the interface. So by the time the train leaves the portal, everything is out there laid out for the customer to see. Now, as the train is passing by and those individual images are generated, we also send them to the AI for processing, because we have to have the results within 15 to 20 minutes of the train departing the portal.
Right.
So those images are gathered real time, sent to the AI for processing, and then detections are packaged and sent to the customer for analysis. Right. That is sort of the high-level overview of how it all works together.
Yeah, that's very good. I think people don't understand that the pictures you're actually taking, I think they're 1 pixel wide.
Yes, right? That is correct. Those are thin slices that are being driven by the LSS, or how fast those slices are taken. Right. And then there is a piece of code we call the stitcher that puts them together, but it puts them together precisely from one coupler to another coupler, right? So we want to have those per car images.
Okay, so one of the things we wanted to also show today is a new solution that we've developed called our oblique view, and basically this is on the underside of the rail car, and we'll go ahead and show you a brief video of this. This is our engineering team out doing a live test at one of our nearby rail inspection portals, and what you can see is we're now inputting the device into the track. You can see how literally the train rides on top of this. So you can see basically 10 cameras looking from one angle, or 5 cameras from one angle, and then another 5 cameras from another angle. It can see an additional 21 inspection points on the underside of the car, and one of those inspection points is called an F pin. It's a particularly difficult pin to see, and it requires a mechanical car inspector to actually get on his hands and knees, get up underneath the train to see that. We can see that automatically while the train is going at high speed. And then this next video here will kind of show you a bit here about the oblique view. Correct video here.
So the oblique view, for our customers, they have to inspect numbers of different items, keep their trains healthy. It takes a lot of man hours to do manually, so we build machine vision systems that do it for them. Either gives them pictures so they don't have to be there physically, or takes the pictures and runs it through an algorithm and finds the stuff for them. And it inspects the parts without them even being in the loop and just tells them when there's a problem. Our team mobilized. We integrated in a way where we were able to communicate multiple times a day with all of the relevant SMEs on hand at all times, so that there was no time wasted. We had enough time to do multiple iterations, make sure we got rid of the stuff that didn't work, select the stuff that did work, and everybody was active and present so that nothing was missed.
Some key leaders stood up. We had some engineers that, actually started from scratch. They took whiteboard lessons learned and they just started documenting.
So it's very difficult to inspect. You have to actually crawl underneath and look at specific things from different angles, which is an awkward position to be in. So we put cameras in that awkward position so that the people don't have to be.
So one, there's many safety issues and concerns about people getting down and bending down and so forth. And it's also very difficult to see this. So what we have been able to do is develop a new oblique view that is underneath the train looking at different areas.
We had to put multiple pose angles, so different cameras, under the train to see all the different things that the customer wants to see, which meant we had a very small space, very tiny volume to put cameras that aren't big, but lamps that are gigantic compared to the volume. These lamps, when they all turn on, are roughly twice as bright as the sun.
We have a total of 10 cameras. These 10 cameras are dedicated towards certain aspects that the customers ask us to look at for certain safety concerns or issues that they want us to look at specific targets.
Through a lot of trial and error and calculations and analysis, we figured, okay, these are what we are going to build. Now, compared to what we've done in the past and compared to the view, which sits on the tracks and looks straight up instead of at different angles, we tried to solve a problem that we've had for a while. So what we did was we built an illumination system that surrounds the camera. So it puts light on all sides of it, and we keep the illuminators very close to the camera's lens so that there's almost no shadow in the images that are acquired. We did a pretty amazing job in a short amount of time to produce a system that I think our customers really will like.
As of today, our system is in production. It is live. It is capturing all of the images into the detailed images that our customer needs.
Okay, and obviously we're pretty excited about this new oblique view. This was developed by our team of engineers in approximately 75 days. So this is a very, very fast development, and I'm really proud of the team and the talent that we have. This chart here basically shows, a little bit of the market opportunity. Obviously, you can see the North American rail network really extends from Canada down to the United States and really into Mexico with Kansas City Southern and Ferromex. And then on the right-hand side, you'll see a number of where all the rail yards are. This is important because basically what the opportunity is to basically put a rail inspection portal as trains enter each of these rail yards, and then as the trains exit each of these rail yards. That's really where you get the full benefit of this, and that's really a strategy that a lot of the Class 1 railroads are having discussions about right now. On the next chart, we're really talking about the rail car inspection process. So the key takeaway here is that right now, the Federal Rail Administration mandates a physical inspection that before the rail car departs a rail yard. Each of the Class 1 railroads require internally an inspection of their rail cars as they enter so that they can conduct maintenance, which is a major line of business for them and a major cost. So again, you've got that dwell time of hours per train, and basically when you talk to a railroader, anytime they have a train stopped, they're basically losing money, and when it's moving, they're making money. So that's really a key metric for a lot of our rail customers. Next, please. So as we kind of talked about here, you can kind of see the value in that, one, the first key thing is improving the safety of the rail customer's operations, improving his velocity, and then which ultimately then is saving a tremendous cost and is of great value to our customers. Next, please. Some of this next chart here shows some of our current customers right now that we're really proud to be able to be partners with. That is CN, CSX, KCSM. We've got some transit rail customers, and then we have other industrial customers that use rail cars that are currently in discussion with us. Very briefly, we'll turn to our automated logistics information system. That is basically using similar technology that we use in our rail inspection portal, but now we're using it where we have large quantities of trucks entering and exiting large logistics facilities. And then on this last chart, before we go to the financials, just some overviews of the company. Bottom line is over the last 6 or 7 months, we've made some tremendous improvements commercially, but right now our focus has been to make operational and technical improvements because we think that will ultimately build us for the future, not only in the current industries we serve now, but in other industries. With that, I'd like to turn it over to my CFO, Adrian Goldfarb, who will touch on our financials. Good afternoon, everyone. I'm just going to cover a few summary slides here, starting with the income statement. Obviously, fiscal year 2020 was a tough year for us. Was somewhat to do with, obviously, the pandemic that hit us right after we did the NASDAQ uplisting. And the good news story to take from that is that we were fortunate in that this wasn't really project cancellation. It was more about project delays. We also had the effect of making some pretty significant management changes, both at the most senior level with Mr. Ferry, and then we also have put in Ben Iser as the Chief Operating Officer. And there was a fair amount of restructuring that went on as around that, including some delays internally of revenues going forward into 2021. So those overall combined for a year that was somewhat down on revenue. Obviously, we continued, although we made some cost reductions, we continued with the expenses we believe we needed in order to keep the company on its development schedule and results in things like the oblique view. 2021, we've made an initial guidance for the year of $18 million for the year, and we are expecting to break even on that. Turning to the balance sheet, what I do here is present both current assets and current liabilities in their gross numbers as reported on the 10K. And then what I'm doing is splitting out on the asset side the cash, the AR, and the contract assets, which are, the real things that provide the liquidity for the company. We'll make a comment that you'll see the cash as of earlier this month was about $7.5 million. We did execute a raise with a couple of our largest shareholders in the amount of $4.5 million at a relatively small discount from the then stock price. Current liabilities are under control, and the good news story there is that the only debt we had at that time was a $1.4 million SBA loan, which was forgiven in Q1. So our balance sheet is not only right side up, but it's in very good shape in order to support the anticipated growth through this year and beyond. Last slide on the financials is the cap structure. Our common stock has changed very little, around 3.5 million shares. We haven't issued any new warrants. The option number has gone up a little bit with some incentive hiring options related to some new senior staff that we've taken on over the last few months. Series B convertible preferred as it was. And then I mentioned the $4.5 million raise, and that gives a common stock equivalent of about 818,000 shares. So the total share count fully diluted is now just under 6.7 million shares. The market cap, obviously the stock price has been rising through most of the early part of this year, is around 30 million on a basic measurement, and then fully diluted is about 40 million. And the questions often come out, if you see the notes there, is that our weighted average exercise price on the warrants, of which a bunch of them are cash warrants, is about $8.80 a share. And with that, I'll turn it back to Chuck.
Yeah, so we got just maybe 2 or 3 minutes for any questions. We have one in the queue. We'll go to that right now.
So I'll go ahead and read the question. So given multi-year trial periods with customers, what do you believe is causing customers to continue to delay a full rollout of the solution? Does the current solution set not yet offer a robust enough result to meet your customers' hurdle rates? Thank you very much for the question. It's a good one. So I think from my perspective, in past years, this technology, this automated rail car inspection technology has been relatively new, and the 3 current Class 1 rail customers that we have really considered that solution really kind of in a test phase. So right now we have about 10 of our rail inspection portals deployed. This past year we've made a number of additional modifications and add-ons to those, and now our current customers are indicating now that we're going to production. So as we go forward, especially with our current customers, they are now ready to fully roll out the solution, which is why we've given the guidance that we have. And we are well aware that several of our Class 1 customers are now in direct conversation with the FRA, to begin that legislative, either relaxing the legislation or changing the legislation altogether. So the point of kind of this being tested is now past, and now we're moving into production. Hopefully that answered that question. We'll check one more time if there's any additional questions. I don't think there are. And we'll just check one last time. Okay, I think we've answered any of the questions that came into the queue. Adrian and I appreciate the opportunity to speak with everyone, and we'll turn it back over to the moderators to finish things up.
Thank you. This does conclude today's webcast. Thank you for your participation and have a wonderful day.